What's happening, everyone? So today's lesson is on finding functions, and what that means is we're going to use integration to be able to work backwards from our derivative to find what our original function was or what our original graph was. So it basically means that if we know what dy by dx was for something, it means us working our way back to figure out what y is. Okay. Now it's going to show you, like a couple of you have kind of commented on a couple of the things that we said last week, asking what I don't even get what C is, and C is the kind of important part of all this. That's the kind of thing that the little sort of extra bit. Why is it there? What does it do? And how are we going to find it? And that's sort of shown through what we're going to do today. Okay, so we'll jump straight into an example. So if we have a look at example 6, the curve C with the equation y equals f of x passes through the point 4, 5. Given that f dash of x equals that function there, find the equation of the curve. Okay, so basically what it's telling us is that that's the gradient function. Find the equation of the curve. Okay, so if I want to get the equation of the curve, I need to integrate this. Okay, I've got the derivative, I've got your differential function that has come from differentiating the original curve. So if I integrate this, it will reverse that differentiation and give me the curve. Okay, so the first thing that hopefully you've spotted there is that I can't differentiate that while it's written like that. So the first thing I have to do is write it as y equals x to the power of minus a half times x squared minus 2. Taking that root x from the bottom up to the top and writing it as x to the minus a half. I then need to multiply out with the bracket. Remember that when you times things with powers, you add the powers. So minus a half, add 2, gives me positive 1.5, which is x to the power 3 over 2, minus, and then that'll just be 2 times that, 2x to the minus a half. So I've got my function y with powers now that I can integrate. Okay, so increase the power by 1 and divide by the new power. Remember, effectively, this isn't y, sorry, that's effectively dy by dx. So now I integrate and it will give me y. So increase the power by 1, that's going to go to x to the 5 over 2. Divide by the new power will give me 2/5 of that. Increase the power by 1, that's going to go to positive a half. Divide by the new power. Dividing by positive a half is the same as times by 2, so that'll end up giving me minus 4x to the half. And remember that we always have to put that plus c at the end. So that is effectively what we were doing last week. That is the function that we get and we integrate this. However, because in the context of the question we're being told that that is the differential, it means that it's come from when we differentiate this. So the c just represents what must have been missing at the end. Okay, and just to kind of show you a little bit about what I'm talking about here and why we've got a little bit more work to do. I hope this works. So, right, on Desmos, I hope you can see that. That there is, if you look there, you've got like an infinity of screens down there, don't you? Right, this curve is the curve of what we've got there. That is the curve of 2/5 x to the 5 over 2 minus 4x to the power of a half. Okay? So the c bit depends as quite a big effect, because if we were to have a number for c that has disappeared, say it was 6, then it would actually look like that. At the minute, we've got that. So that number tells me which one of these curves it's going to be. It tells me where it's going to go through the y-axis, which is really, really important, because without that, we don't know what the actual curve was. So we could be using this curve when really we should be using this curve. Okay, so that's why it's important to figure out what c is. So if I go back to me working out, what I now need to do is figure out what that c is. And to do that, I'm going to use that coordinate, because I know that that curve passes through that coordinate. So I know that when x is 4, y is 5. So I can sub those two things in there, can't I? So I can say that y is 5 when x equals 4. Okay, and then if I plug all that into my calculator, I end up with, let's see what this is, that's 2/5 times 4 to the power of 5/2 minus 4, that's going to give me 2, isn't it? Square root of 4 is 2. That gives me 24/5. 5 equals 24/5 plus c. So if I do 5 minus 24/5, it gives my answer to tell me that c is a fifth. Okay, so what I can now do is replace that c there with a fifth, and it gives me the full answer for the curve then, doesn't it? It tells me that y must equal 2/5 x to the 5/2 minus 4x to the half plus a fifth. Okay, so that's your full function there, and we've got that by working backwards from our differential and knowing what coordinates it goes through. Okay, so it's kind of similar to the work on figuring out your equations of lines and things like that. Okay, so can you make sure you got that copied into your book, please, and then can you have a go at questions, excuse me, questions 1A, 2, 3, 4, 5 and 6, please. Okay, any questions about that, just drop us an email or comment on Classrooms or on Teams, and then can you upload a photo of it to Classrooms or Teams, please, when you've finished. Okay, good luck.